Have you ever seen strange results when rounding numbers in a programming language? If you've been programming for a while, it's very likely that you have. In this video, I'm going to explore this tricky subject and trying to figure out why. Rounding is to replace a number with a shorter, simpler, or more explicit representation. It is an old concept. Some ancient clay tablets found in Mesopotamia contain rounded reciprocal values and square roots in base 60. Other examples of ancient rounded values include pi, the length of the year, and the length of the month. When I was little, my teacher told me that to round a decimal value to the nearest whole number, we should round up if the 10th digit is greater than 5, and round down if the 10th digit is less than 5. In the case of the 10th digit is exactly 5, we can simply round up. For a long time, I believed this was the only way of rounding numbers. However, my belief was challenged after I learned programming. One day, I spent several hours debugging a program I wrote. I was certain my code was correct, so I could not understand why the result was different from what I'd expected. It turned out to be the rounding. First of all, there are more than one way to round a number. The method my teacher taught me is called round half up. That is, halfway values are always rounded up. Take the number 4.5 for example. 4.5 is perfectly halfway between 4 and 5. Using round half up, 4.5 gets rounded to 5, and negative 4.5 gets rounded to negative 4. Opposite to round half up, there's round half down, where 4.5 gets rounded down to 4, and negative 4.5 gets rounded down to negative 5. Then there are round half towards 0 and round half away from 0. As the name suggests, using round half towards 0, 4.5 gets rounded to 4 because 4 is closer from 0 than 5. While using round half away from 0, 4.5 gets rounded to 5. Another pair of rounding rules are round half to even and round half to odd. By the round half to even convention, 4.5 becomes 4 because 4 is an even number, and 5.5 becomes 6. Using round half to odd, 4.5 becomes 5, and 5.5 also becomes 5. Since there are different rounding methods, when we perform rounding in a programming language, which method are we actually using? I did some research on the default rounding method of some popular programming languages and found that languages such as Python, R, and Kotlin are using round half to even. JavaScript, Java, and PHP are using round half up. Go, C, and C# are using round half away from 0. Of course, most of the languages have implementation or workaround if you want to use other rounding methods. However, knowing the rounding method you are using, will you always get what you expected? The answer may be surprising to some people. Let's run an example in Python. If I want to round the float number 2.675 to 2 digits, I would expect to get 2.68, right? Now I run the code. I get 2.67 instead. Is it a bug? No, it's not. It is because that most decimal fractions can't be represented exactly as a float. Computers are based on electrical elements that have only two states, usually low and high voltages. It's natural to store numbers in binary. However, binary can only accurately represent those numbers as a finite fraction where the denominator is a power of 2. Unfortunately, for most of the numbers, this is not the case. Like 0.1, the binary fraction is this, which is close to, but not exactly equal to the true value of 0.1. Of course, Python only displays the decimal approximation of the true values stored in the machine. Therefore, many people are not aware of these numbers are approximation. On most machines, If Python were to print the true decimal value of the binary approximation stored for 0.1, it would have to print something like this, which means the number 0.1 and this long number share the same approximation value. The proof is that if you print 0.1 double equal to this long number, you will get a true. This binary approximation will cause strange behaviors not just in rounding, but in other types of calculations too. For example, because 0.1 cannot be approximated exactly, summing three values of 0.1 is not going to give you exactly 0.3. The workaround is applying rounding once the values have been summed. Then you can compare the results. This is the limitation of processing floating point numbers on a computer. It is not a bug in Python, nor is it unique to Python. You can observe it in all languages that support your hardware's floating point arithmetic, although some languages may not display the difference by default. So, in a word, rounding could be trickier than you think. A computer language can use a different rounding method, or the rounded number could be unexpected due to binary approximation. Here's a fun fact. According to Mark Raymond, NASA's mission manager and chief engineer for the Dawn mission, NASA rounds the constant pi to the 15th decimal place. It turns out, by cutting pi off at the 15th decimal point, the calculated circumference of the 25 billion mile diameter circle would be wrong by only 1.5 inches. How impressive! I hope you learned something new. If you like this video, please click the like button and subscribe. Thanks for watching and see you next time.